So let's take a look at the product and quotient rules. So now starting off with the product rule, let's say you try and take the derivative of two functions u and v being multiplied by each other. Then the formula to use the product rule is going to be u prime v plus v prime u. So the derivative of the first function times the second unchanged plus the derivative of the second function times the first unchanged. And now for the quotient rule, let's say you're trying to take the derivative of one function divided by another. So in this case, let's just say u divided by v. Then the formula to find the derivative is going to be vu prime minus uv prime all over v squared. So another way to remember this is by saying low times the derivative of high minus high times the derivative of low all over low squared, or low d high minus high d low over low squared. So once again, remember, when you have two functions being multiplied or two functions being divided, you have to make sure you use the product and quotient rules. So for example, in the product rule, when you have u times v, you cannot just take the derivative of u, take the derivative of v, and multiply them. You have to use this exact formula. So let's go ahead and differentiate. So for number one, we have f of x equals x squared times e to the x. So notice we do have two functions being multiplied by each other, so we have to use the product rule. So once again, the product rule, we have two functions u and v being multiplied by each other, and then we use the formula u prime v plus v prime u. So for this example, I'm just going to go ahead and label x squared as u and e to the x as v. So the formula, once again, is going to be the derivative of the first function, so derivative of u, which is 2x, times the second function unchanged, so that's just e to the x, plus the derivative of the second function, derivative of e to the x is e to the x, times the derivative of the first unchanged. That's just x squared. So then we get 2x e to the x, and then plus x squared times e to the x, and that is going to be the final answer for the derivative f prime of x. So now for number two, we have y equals e to the x over x squared. Because we do have e to the x divided by x squared, we have to use the quotient rule. So if I go ahead and say the derivative, I'm just going to write out the formula of one function u divided by another function v is going to equal vu prime minus uv prime over v squared. So let's go ahead and label e to the x as our u. So that's going to be u, and then x squared is going to be v. So once again, using the formula, we're going to take the lower function, x squared, times the derivative of the higher function, derivative of e to the x is e to the x. So low d high minus high, which is e to the x, times the derivative of low. The lower function is the derivative of x squared, which is 2x, all over the lower function squared. X squared squared is the same thing as x to the fourth. So then we can go ahead and simplify. We get x squared e to the x minus 2x e to the x over x to the fourth. I can go ahead and factor out x from the numerator. So we'll get x times x e to the x minus 2 e to the x all over x to the fourth. And then I can go ahead and cancel out one of the x's. So then we'll get x e to the x minus 2e to the x all over x cubed. And that's going to be the final answer for the derivative. So now for number three, we have g of x equals 3x minus 1 over 2x plus 1. Because we do have 3x plus 1 being divided by 2x plus 1, let's go ahead and use the quotient rule. So once again, for the quotient rule, we're going to take the lower function, so 2x plus 1, times the derivative of the higher function. Derivative of 3x minus 1 is just going to be 3, minus the higher function, so 3x minus 1, times the derivative of the lower function. Derivative of 2x plus 1 is 2, all over the lower function squared, so 2x plus 1 squared. And I'm actually going to leave it as it is. I'm not going to go ahead and FOIL the denominator, but I will simplify the numerator. So let's go ahead and start off by distributing 3. So we'll get 3 times 2x plus 1, that's going to be 6x plus 3. Then minus, we distribute over the 2, we'll get 2 times 3x, 6x, 2 times negative 1, negative 2, all over 2x plus 1 squared. So then we can go ahead and I'll distribute the negative inside the parentheses, so we'll get 6x plus 3 minus 6x, we get plus 2, all over 2x plus 1 squared. And then go ahead and simplify. The 6x and negative 6x will cancel. 3 plus 2 is 5, so we'll get 5 over 2x plus 1 squared. And that is going to be the final answer for for the derivative of g, or in other words, g prime of x. So now for number 4, we have v of x equals 2x cubed plus 3 times x to the fourth minus 2x. Realize since we do have two different functions being multiplied by each other, we go ahead and use the product rule. So in order to derive with using the product rule, once again we first take the derivative of the first function. So derivative of 2x cubed plus 3 is going to be 6x squared times the second function unchanged, so just times x to the fourth minus 2x, then plus the derivative of the second function. Derivative of x to the fourth minus 2x is going to be 4x cubed minus 2 times the first function unchanged. So the first function is just 2x cubed plus 3. So now I can simplify by distributing the 6x squared. So we'll get 6x squared times x to the fourth is 6x to the sixth, minus, we get 2x times 6x squared, that's 12x cubed. And then plus, now in order to simplify this, we just have to go ahead and FOIL. So we have 4x cubed times 2x cubed, that is going to be 8x to the sixth. We have 4x cubed plus 3, that's going to be positive 12x cubed. Negative 2 times 2x cubed is going to be negative 4x cubed. And then we have negative 2 times positive 3, that's going to give us negative 6. So now in order to simplify, we have 6x to the sixth plus 8x to the sixth, that's going to be 14x to the sixth power. We have negative 12x cubed plus 12x cubed, that will cancel. And then we do have negative 4x cubed. And then finally we have minus 6. And that's going to be the final answer for the derivative using the product rule. So now for number 5, we have y equals r squared minus 2r times e to the r. We do have two functions being multiplied by each other in this case, so we can go ahead and use the product rule. Now realize that instead of the x variable, we do have the r variable, but that doesn't matter because we treat it the same exact way. But instead of deriving with respect to x, we're going to go ahead and derive with respect to r, because that's the variable that we are deriving. So once again, using the product rule here, we're going to take the derivative of the first function. So in this case, the derivative of r squared minus 2r is just going to be 2r minus 2 times the second function unchanged, so just times e to the r, plus the derivative of the second function, so derivative of e to the r is just e to the r, times the first function unchanged. That's just going to be r squared minus 2r. If I go ahead and simplify that now, I can go ahead and distribute the e to the r. So we'll get 2r e to the r minus 2 e to the r, and then plus, I go ahead and distribute to those parentheses there, and we'll get r squared times e to the r minus 2r e to the r. Now notice positive 2r e to the r and negative 2r e to the r will cancel, and so we're left with, I'm just going to go ahead and rearrange the terms. So we get r squared e to the r minus 2 e to the r. That's going to be the final answer for the derivative. Now for number 6, we have y equals 1 over x to the fourth plus x squared plus 1. Now there is a better way to derive this using the chain rule, which we'll learn later. But for right now, let's go ahead and use the quotient rule. So once again, we're going to take the lower function, so x to the fourth plus x squared plus 1, times the derivative of the higher function. Derivative of a constant is just 0, minus the higher function, that's just 1, times the derivative of the lower function. So derivative of x to the fourth plus x squared plus 1 is going to be 4x cubed plus 2x, and then all over the lower function squared. So we have x to the fourth plus x squared plus 1, the entire thing squared. And I'm not going to FOIL it, I'm going to leave it as it is. Now simplifying here, we have 0 times x to the fourth plus x squared plus 1, that will cancel. Now 1 times 4x cubed plus 2x is just going to remain as 4x cubed plus 2x, so I can cross that one off. And then I can go ahead and distribute the negative. So then we'll get negative 4x cubed minus 2x all over x to the fourth plus x squared plus 1 squared. And that's the final answer for y prime, or the derivative.